Okay, today we're going to talk about solving by substitution. So solving linear systems by substitution. So the first thing that we have to do is we have to isolate the variable on the side by itself, a variable. It doesn't matter if it's the x or the y. In this case, we do have the y that's isolated. But it can be the x as well, whichever is going to be easiest. The second part of this, the second step, and this is where the name comes from, is to substitute its value into the other equation. So what that means is since y equals 4x minus 6, we're going to substitute that in for y in the other equation. So when we do that, we get 5x plus 3 times, what does y equal again? 4x minus 6, put it in parentheses. 4x minus 6 equals negative 1. So we just substituted that for the y in the other equation. Step 3 is going to be solve for the remaining variable. So in this case, we're going to distribute. Once we distribute, we're going to get 5x plus 12x minus 18 equals negative 1. Combine our like terms. 17x minus 18 equals negative 1. Let's go ahead and add 18 to both sides. Those zero out. We get 17x equals 17. We still have to solve all the way. So how do we get rid of the 17 in front of the x? We divide both sides by 17. And we get x equals 1. Okay, so right now we only have one variable. Also, you can only solve for one variable at a time when you're using either substitution or what we're going to talk about on Friday, elimination. So step number 4 is going to be substitute. We're going to use that word again. Substitute this value into either equation then solve for the other variable. So I'm going to go ahead and pick the top equation because it looks easier. So we have y equals 4x minus 6. So we're going to substitute this value in for x right there. So we get y equals 4 times 1 minus 6. Oops, there we go. Let me scooch that up. So we get y equals 4 minus 6, or y equals negative 2. Then the very last step, step number 5, is to write your answer as an ordered pair. And so step number 5, so our answer is going to be 1, negative 2. So our answer is 1, comma, negative 2. Boom, there's our answer. Okay, now let's have you try one of these. So you do it. And let's do example 2. So for this one, let's have 2x plus 5y equals negative 1. Whoops, there we go. I need to keep looking at the screen. It's going to be our first equation. Our second equation, negative 3x plus y equals 10. Okay, now pause the video and let's see what you got. Okay, well here we go. So step number one was to isolate a variable. This second equation right here looks like that's going to be the easiest one. And so I'm going to go ahead and add 3x to both sides. And when I do that, I get y equals 3x plus 10. So now I'm going to substitute that value for y in the other equation. So when I do that, I get 2x plus 5y, but y equals 3x plus 10. And that equals -1. I didn't leave myself a lot of room here, but we'll make it fit. Distribute the 5. So we end up with 2x plus 15x plus 50 equals -1. Combine our like terms. 17x plus 50 equals -1. Subtract 50 from each side. We get 17x equals -51. Let's just go right over here, and then we have 17x equals -51. Divide by 17. And we get x equals -3. Okay, so now I'm going to substitute this value into this equation that I already rearranged, because that looks like that's going to be the easiest. So when we do that, we're going to get y equals, I'm going to do this right over here. So y equals 3 times, what does x equal? -3 plus 10. Or y equals -9 plus 10, or y equals +1. So that means that the answer for this, which I'll put right over here, is going to be -3 is the x value, 1. Okay, there we go. So now let's try another example. And this will be example 3. And let's do y equals 2x minus 4 and -6x plus 3y equals -12. Okay, so isolate the variable. That's already done with the top equation. So let's substitute its value into the other equation. We're going to substitute right here. When we do that, we get -6x plus 3 times 2x minus 4, because that's what the y value equals -12. Distribute here, we get -6x plus 6x minus 12 equals -12. Combine our, oh, this is weird, we get -12 equals -12. So now we did some of these before when we had variables on both sides. But if we get something like this is a true or false statement. -12 does equal -12, so it's a true statement, which means that our answer is going to be infinitely many solutions. The answer is not true. The answer is infinitely many solutions, which means that those two are the same line. So just like with the graphing, they're either going to intersect in one place, they're going to intersect everywhere when they're the same line, or they're going to be no solution, which means they're going to be parallel. And so let's just do a quick little example 4. I'll go ahead and show you. We'll do it all the way. So this is going to be 2x minus y equals 8. And y equals 2x minus 3. So again, it's already isolated. So let's plug this in for y in the other equation. So we end up with 2x minus 2x minus 3. Always plug it in parentheses. Equals 8. Or 2x minus 2x plus 3 equals 8. Here we get 3 equals 8. Is that because our 2x's zero out? Is that a true or false statement? This is false. Therefore, remember, the correct answer isn't false. The correct answer is no solution. Please let me know if you have any questions about any of this, and enjoy.